also going to make it easier for you to understand by showing some good use cases as well. So let's jump right in. Okay, by the end of the session, you should be able to get a general overview of stored procedures and UDFs. You should also be understanding how the UDFs and SPs perform and the best practices to use which one over the another. This session is useful for us, the RPG developers, and the DB2 SQL developers as well, and any IBM I business owners trying to modernize their application. So without further ado, let's get started. All right, what is a stored procedure? A stored procedure is a compiled program that can execute SQL statements. As you all know, there are many ways to run SQL queries. Traditionally, the green screen where we run the str SQL, and we can also embed them in the SQL RPGLE programs, or the run SQL statements window in the ACS, right? But the main difference between running the SQL queries traditionally and to have them inside a stored procedure is that stored procedures are actually compiled code. So when I say compiled code, during the compilation, the syntax errors will be checked. And on the other hand, when you run the SQL queries on the traditional way, queries are interpreted at runtime only, and they provide only limited to no syntax checking. On the other hand, SPs, aka stored procedures, we have, since it is a compiled program that comes with the syntax checking, and we do have the program object that got created, and it will be stored inside the DB2 database itself. And to put it in a simpler way, SPs, that is stored procedures, are like running the str SQL, but with some special powers. By special powers, what I meant is we will be able to use the loops, we can implement the conditional logic, we can use code blocks to represent different parts of the code, and we can also pass the parameters in and out, right? And because of the fact that the object is stored inside the DB2 database, not only the RPGLE programs can use it, any modern day application that has access to the DB2 can make use of the SQL stored procedure. So that is all about the introduction. Now let's go ahead to see the why part. Why stored procedures? To start with, it reduces the network traffic. I want you to think of this example where we are going to display hundreds of records on the front end, right? And the traditional way of displaying those records, we might be using SQL cursors to fetch every of those records, and then we'll be displaying it one by one, right? And that will create a huge network traffic between the client application and the server. Instead of that, what if I can get all those hundreds of records in one shot? Yes, that can be possible with the help of stored procedure. And because of the fact that I'm getting everything on single shot, it will minimize the locks on the resources. And speaking of the locks in the IBM I ecosystem, object locks are pretty consistent. We'll be getting such locks every now and then on the production systems, right? And it also provides us the centralized code, and it also gives us the code reusability. Think of the application where we'll be running the same SQL queries across different pages, right? It'll be hard for us to manage the SQL queries across various front-end screens. And instead, we can write one stored procedure, and we can invoke that stored procedure across all the screens. It also provides security and integrity. End users can manipulate the SQL statements and variables if we don't wrap it around or if we don't mask it, right? But SQL stored procedures, they are by itself, the end users will not be able to manipulate the SQL statements, and thus it provides a security. And modernize by opening up the IBM I to the front end. We'll talk about it in the coming slides in detail, and it'll be easier for the cross-platform users to understand. Just like SQL is the de facto querying language for the databases, it'll be easier for the cross-platform users such as Java, Python, or Node developers to understand the code better. And last but not least, it's a good skill set to have for us, the IBM IE developers. Okay, I think you should be able to understand the difference between the traditional method versus the method where we utilize the stored procedure. On the left-hand side, you are seeing this diagram where we have an application that interacts with the server, right? And please think of this scenario. My motto is to uh, execute 3 statements and get the output of those 3 statements individually and to make a logical decision. As you can see, first the client will request for a uh, uh, he will request for a resource, and then the server will respond back with the output. And then the same thing will happen for the second time as well. And during that, my client application will do the logical decision making. And then finally, it will ask for the statement number 3 to execute. And by that, we'll be getting the final result. So this whole process took at least 3 transactions to and fro between the client and the server. On the other hand, on the stored procedure, we have all these things wrapped inside a stored procedure, and that stored procedure is also residing inside the DB2 database itself. So the client has to do one SQL procedure call. That call will do all these things one by one. It will also make the logical decision as well. And then at final, it will pass the result back to the client application. This way, stored procedure will make the lives of the developers easy. Moving on. When I talk about the modernization and security, I want you to listen carefully, please. Stored procedure is the first step in modernizing the IBM I. And the best thing is we get to utilize modern languages in our application without abandoning the trusty IBM I server. Nowadays, IBM I is natively supporting popular programming languages like Java, Python, Node.js, and PHP. So if you want to modernize your application, you can choose any one of these languages. Or if you want to host your application elsewhere, you can also make use of the languages such as .NET, Golang, Kotlin, or Perl. In such case, the ODBC is your friend. Via the ODBC connection, you can have direct connection to the database. And by itself, we also have all the possibilities that we can do with the stored procedure. And I want you to think of this scenario where the IBM I application, right? Let's say we have an ERP application developed and enhanced in RPG over the period of 10 to 15 years. And if the business tries to modernize it, then the business owners will be hesitant to modernize the entire code base to the new languages. In such case, the stored procedure will come into rescue. How? We can use the existing legacy code such as RPGLE, CL, and COBOL, and uh, uh, we can use these existing legacy code to take care of the core business logic and wrap their execution around simple SQL procedure calls. Let's say we have a front end that will have access to the application layer, and through this application layer, that could be Java or Python or anything that will have access to the database, and this application will invoke a call to the SQL procedure, and that will in turn will have access to the internally present RPGLE, CL, or COBOL program objects, which will do the math, do the calculation, do all the computing. Then it will pass back the values back to the stored procedure, which will in turn pass it back to the application layer. That way, it will be easier for the uh, uh, owners of the legacy applications to modernize their application without changing or touching their core business logic. And apart from the fact that it provides us modernization, it also provides us more security. Of course, all the application layer will have their own model of security. And on top of that, we can also have additional layer of security where we can provide the security inside the DB2 database itself. Right? Using the IBM I's native object-based security, we can provide additional layer of security for the application. All right. And speaking of which, there are two types of stored procedures. One is the internal one, and the other is the external one. So what are all these? Internal stored procedures are nothing but, let me go back to this previous slide again, where the front-end application will raise a request to the stored procedure, and all these things will be happening inside the database itself. Whereas for the external one, it will pass back the the control to the existing IBMI objects, and then it will pass back to the stored procedure. So that is the main difference that I want you to understand. So internal procedure by itself, it is nothing but it is based on the extension of SQL language. However, the external stored procedure is nothing but we have access to high-level languages such as C, CL, RPG, and COBOL. Internal stored procedures are mostly preferred to do straightforward database manipulation, and it is best suited for simple applications. However, if you want to do some complex and sophisticated processing, such as using DS or built-in functions or data queues and whatnot, then we can go for the external stored procedure approach. And for existing systems, the business logic need to be ported to the SQL language, whereas the legacy code can be reused. And because we have the access to the native IBM objects, it will provide us the facility to access those native IBMI functions. Now let's take a quick look at the structure of a stored procedure. So I can broadly classify into three parts. One is the declaration part, and the specification part, and then the procedure body itself. On the declaration part, we'll be declaring the stored procedure name and also the parameters. The parameters could be in or out or both in and out as well. And on the specification part, this is where we'll be specifying about how the stored procedure works. Is it going to be reading or modifying the SQL data, or the language is going to be SQL or RPGLE? Is it going to be deterministic or non-deterministic, etc.? And we'll talk about, we'll see about these things down the line. And the body itself, where we can manipulate the database using various SQL queries and whatnot. Okay, now moving on to the user-defined functions. So many people used to confuse between the UDFs and the stored procedures, mainly because both are happening inside the DB2 database itself, but there's a slight difference between them. So what is UDF? UDFs are custom functions created by developers within the DB2 database on the IBMI. Think it like the usual built-in function that we have in the RPGLE, but where we can create our own built-in function to serve some particular purpose, right? And it can encapsulate the SQL logic and can return a single value, that is the scalar UDF, or an entire table itself, that is a table valued UDF. We'll see about this down the line. And just like the stored procedure, the program object is stored on the DB2 database itself. And it can be invoked only in the SQL statements. We cannot just call the user-defined functions independently. It has to be inside the SQL statements. And why UDF? It provides us modularity and code reusability. That is, break down the complex logic into smaller pieces, reusable pieces. Take an example of running custom SQL reports. The user doesn't need to write the SQL query every single time. Let's say if they want to do some basic manipulation, like doing some mathematical calculation between the order amount and then the order value, etc. They can write a simple user-defined function to do those manipulation only once and be done with it. By invoking the same user-defined function every time, it'll be easier for them to run the custom SQL reports. And performance optimization. UDFs can improve query performance by pre-computing the results or handling the tasks that are repeated efficiently. So let's say we have an example of where we're supposed to find the day of the week, right? So the input is the date that is already present on the table. And if I want to find out the day of the week, then I don't need to alter the table to add a new column and I have to populate that. I can just do it by creating a simple user-defined function. And data formatting on the fly. Let's say I want to do some complex data formatting, which will include two or more built-in SQL functions. I can encapsulate those functions inside a new UDF, and I can call that new UDF instead of calling those two individual functions separately and find out my result. We can see, and we'll be seeing all these things in the coming slide as an example. All right, I'm going to switch back to my VS Code now to show you the examples. All right, so we have the first example of where we are going to populate a particular set of records to my employee table. I'm sorry, to my department table. So the first line, like I said previously, that is the declaration or definition of the stored procedure. And the next part is the specification. As you can see, the language is SQL, and it is not going to send any result sets back. It is going to modify the SQL data because I'm going to populate some data into my table and I'm going to add them into my table. And the specific name is nothing but the name that where we used to give on our IBM I server, because IBM I server object name has to be within 10 character limit, right? So the UDF and the sort process can have more than 10 character of length for its name. But however, if you're going to manipulate or if you're going to view the object on the IBM I, we have to have the 10 characters, right? So for that purpose, we have to specify this name. And here comes the actual body itself, where I am just simply populating these work variables, and then I'm inserting the records onto my department table. Let's take a quick look on the results. Yep. So yeah, let me show you the number of records that are present on my department table now. As you can see, there are only 10 records. And now I'm going to invoke this sort procedure by calling this command. And if I call that, I will be having 5 more records on it. See, now it's 15, right? And moving on to the next example. This is where I'll be inserting a particular record to the employee table, but this time I'm going to pass some parameters. So I decide what record that need to be inserted into it. Just like the previous example, we have everything is the same, but the only difference is that we are having some input parameters over here. And if you take a look at the example, okay, first of all, I'm going to show you if there are any records with the employee number 1001. And then I'm going to call my procedure with these parameters. And once it is done, I should be able to view that record. As you can see, apart from the parameters that I passed, my procedure, I have written the code such a way that it will be all these other variables will be automatically populated. And now let's go to the next example, where we have both the in and out parameters. So my motto is to get the senior most employee from a particular department. By senior most employee, I calculate that by looking at their date of birth. Okay, so the logic is very simple. Right. So I have to create a variable to hold the results, which I'll be doing now. And I'm going to get the senior most employee from the department 939. To do that, I'm going to call this procedure. And if I check the value, we should be getting it. This is the employee and this is the date of birth. Okay, and moving on to the next example where we have result sets. And all these examples, we have only talked about having to send only one data at a time or only one row at a time. What if I want to send a bunch of records in one shot? So that is where we will be specifying the result sets here. And to use the result sets, we have to declare a cursor and then we have to open the cursor and end the procedure. That's it. As simple as that. Let's get the list of records. I'm sorry, let's get the list of employees that belong to a particular department 939. If I call it, you should be getting all these records and the department are all 939. And one thing to note is that we have this thing called catalog table. So whenever an SQL procedure or the UDF is compiled, the values will be added onto this catalog tables where we can check the basic information such as what is the specific name and what is the routine name and what is the short name and when it got created, all these things. So think it of like a DSP PGM, okay, but in a much fancier way. It also has the routine definition as well and the number of parameters, whether it has any result sets or not. You can check all these informations by using this qsys2.sysprocs table. And let's move on to the next set of example, that is to call the external sort procedure. So for this example, I'm going to show you a simple example of where I'm, the example where we have this data queue, and I'm going to populate the data queue that is present inside the IBMI server using a sort procedure. And this sort procedure will be calling my RPGLE program that is called send data queue one. And as you can note here, this takes three input parameters, only three input parameters, and there is no output parameters. And the language is not SQL this time. It is going to be RPGLE. And by the word non-deterministic, what I meant is that if I specify it as deterministic, then the SQL procedure will not be, it will be called, but the actual process will not be happening every single time because it will save the output into the cache memory. And whenever we pass the same parameter over and again, it will take the result from the cache memory and then it will give it back to the calling program. Okay, so this is my send data. And let me show you the receive data as well so that both work in hand. Oh, here it is. All right. So this what it does is, so I have to pass the data queue name and the data queue library and the output variable where the data queue will be read and it will be passed back to the calling program. And here I'm going to call a different SQL, I'm sorry, a different RPGLE program called receive data queue one. Now let's see it in action. All right, now I'm going to populate my data queue with the first line. So the data is going to be as the first line. Okay. And now I'm going to populate the second line. And while retrieving the data queue, I have to pass a host variable. And this is my host variable. And if I retrieve it, and if I check the value, I should be seeing the first line. And if I again retrieve it, I should be getting the second line because data queues are they work in first out method. And if I do it again, it'll be the second line. But if I run it again for the third time, I should be getting a null value because nothing is staying on, nothing is left on the data queue, right? And moving on to the UDFs. Yeah, like I told you, there are two different types of UDFs. One is the scalar and one is the table-based UDF. So here I'm going to create a function, and in the function we can only pass the input parameters, and the output parameters will have to be either a table or a single value. So I am passing a parameter with a length of 500, and I'll be returning an output parameter with the length of 255. And it is going to be deterministic, meaning whenever I am calling this function, and if I'm passing the same parameter over and again, it will not be executed. It will save the result from the cache memory. Okay, and it just extract the file name from the fully qualified IFS path. Let's see it in action. So this is my fully qualified path, and my user function will only extract this file name alone. Let's try it. Yeah, as you can see, this is getting extracted. So if I just rename it to name.sfx, it'll work. All right. And now moving on to the scalar function, but we'll be doing some mathematical calculations. So the purpose of this function is to populate the day of the week. When I pass a particular date variable as an input, it will find out which day is it. So that is what it does. And there are no, and the both the I mean the previous UDF and this UDF share the same specification. Nothing is changed here, except for the fact that we are going to return a 10 length character back. Okay, now I want you to take a close look at this query. I am embedding this UDF inside my SQL query. Okay, so as we have all seen, we have only the birth date on my employee table. Okay, and I'm going to add a new column as day of week. Okay, and where the day of week has to be Sunday. Please note that I have added a new column here, and that column is actually built using an UDF, and my where condition is also built using an UDF. So these are all the employees who was born on the Sunday. Okay, and let's move on to the table functions. Not only we can pass back a singular value to the calling statement, we can also return back a full table itself. And to do that, we have to modify this return clause as return table, and we have to specify what and all that we want to return back. And the language is SQL, it is deterministic, and I have given the specific name as Sure Department. All right, and let us see that in action. And if I pass the department name as a parameter, it will show only those records and only those selected fields as well. The employee name, the first name, and then the department number. It will be passed back to the calling program. Yep, as you can see below here. And just like the catalog tables for the stored procedures, we also have a separate catalog table for the function that is called sysfuncs. And we can check the functions about what it does and what parameters are there, and whether it's in SQL or an external. All these things can be checked using these catalog tables. Yep. And with that, let me hand it over to Yogesh to talk about the enhancing the performance of the stored procedure. Over to Yogesh.
Yeah, thanks, Ravi. Let me share my screen. Hope my screen is visible to all. Yeah. Okay.
Yes.
Yeah. So In modernized application, nowadays we are accessing data in multiple layers of softwares and in different programming language. And most frequently, we are achieving this by doing any connecting to a database and retrieving multiple rows or result sets, and that will be executing or computing some data and producing the result on the screen. And there are some internal repetitive tasks that we need to be completed, where stored procedure give us a hand to do it quickly and crisply. So till now, Ravi have covered how to create a stored procedure and UDF, and how to use and access those with some examples. And till now we know like why and how to use that database. So now, before going to talk upon enhancing performance, we should be uh, we should be going through how stored procedures are compiled and executed. So talking about SQL stored procedures, at the time of compilation, the compiler segregates the stored procedure into two different topics. One, you can say like procedural logic, and another seems to be SQL queries. Here, procedural logic, we can keep it as an dynamic linked libraries, where we do have a set of how loops are going on, and how each and every step is getting executed. SQL queries in terms of to maximize the performance of SQL queries, those are compiled statically, and keeping it into a SQL package, and these are a set of pre-compiled one. Uh, in terms of functions, altogether what we have implemented inside the function, it will be all SQL queries. Again, that will be converted into a static stages, and will be stored in a SQL package that will execute at the time of SQL function is called. So now we'll come to the execution way. Whenever stored procedure is getting executed, it will start with the procedural logic, and step by step it will deal with all the steps those are involved in procedural logic. And as and when required, it encounters SQL queries, it will execute those query by switching on to and database engine side. Altogether, this will be happen in database layer of the system. And here, whenever you are doing with the switching between procedural logic and which are dynamic link libraries, and SQL queries, which are static one, and SQL queries will be definitely execute in less number of time. So that's the reason, like when we are going to design any application, it is advisable, like if we are having some sort of examples which can be retrieved through the database, and it's just assigning back to a caller in that function. It is better to have a function, and in case of some complex query, it should be a stored procedure. I have given this one with this good example. One is here on left hand side, we can see a stored procedure with same body type or logic we have implemented. And here comes like we are retrieving a product price from our V1 table, and it will be passed back to vendor one or vendor two, which is passed to a parameter. So in such case, since it is having uh, only one procedural things that will return the price and return it back to the caller. So it is good to have it converted into a user defined function or UDF, which will be having only two parameters, that is vendor and PID of vendor, and it will returns back the decimal value of your price according to what vendors we have specified over here. So it's good to have functions wherever small scalar and deterministic logics is been applied, which will boost the performance. Second thing, at the time of compilation, whenever we are compiling any service program, its attribute is CILE. It means like it will convert uh, all the logic into C statements, and that will be executed at the runtime. Um, but yeah, since this is a C statements and it will be a bound procedure call, it will take some small sort of time to execute. That's the reason IBM have given us some one special type of characteristics to be configured at the time of creation. One is program type. If we are defining any stored procedure with a program type as a sub, its attribute would be a service program type, which will provide us all the characteristics of activation group and all of service program that will definitely boost the performance of uh, execution of that stored procedure. So as and when required, if we are executing or calling a stored procedure inside some another one, it's advisable to keep it as an program type as an sub. So that will give us a little bit boost of execution. Moving on to next slide. Here, yeah, I will give one example in on left hand side block. Let's say we do have one set of database which will be having a list of employees in a department, and there is one requirement, like we need to calculate all the tasks performed by the employees and store it in employee ways. So in traditional way, what we do, we will loop into the uh, employee table in the department, and will calculate their task perform in week in some another procedures. So what here what will be doing at the time of execution, for each number of loops, it will program will context switching between a normal procedural logic to stored procedure way, that is static way. That will really brings down your performance. So alternative to that would be, we should be consolidate all the two tables or two loops into one and execute them in separately, so that there would be only one store procedure call and it will give get back the result altogether. Coming on to the next points. Yeah, um, it's better to have a single statement to assign a variable from one value to another one. See here in example, like here we have variable 1, variable 2 and 3, and those are executed in three distinct lines. Surely this can be segregated into one line, and it will really do some good use of your buffer memory and do it in a quicker way. Same thing we can execute for inserting a multiple rows into a single table with multiple values. That surely we can do it in a quicker way. one step by using values and three different rows together. And really this one will be reduce performance by 1/3 of time, and uh, altogether the same outcome will be there for that program. Moving on to the next, like whenever it's advisable to have a very minimum temporary variables inside your stored procedure or any application logic. So because like whenever you are executing any stored procedure, as we have seen, there will be a continuously having switch between static memory allocation. And if we are using temporary variables, the surely program will requires a kind of bigger memory to execute, and that will surely reduce performance a little bit. Instead of that, we can avoid and keep it in separate way. We can use any expression, regular expressions that will be executed in one row and get our desired result. Here I have given example of like here counter is set to a particular value, and variable 2, 3 and 4 have been initialized accordingly. So finally here we can see altogether we do have only variable 4 requirement that needs to be initialized with the proper value. So these we can be converted in one scalar statement, so that the counter variable should only be the requirement, and we can get it converted into our variable full value at the last. Moving on to next. Yeah, as we have seen two slide earlier, whenever we are compiling any code, it is converting the object attribute as an CILE concept. So it's better to use wherever possible if we are using any character data type flags. So we can convert it into integer data type so that it will be accessed more quickly. And if in case of we are using SQL statements, it's better to use integer data type, since it is integer data type is native data type for SQL, and instead of like using decimal with zero scale, like zoned and packed decimals in we usually doing in RPG programming. So and next to that, it's whenever required and whenever we are using calling of stored procedures, it's very much advisable, like we should be using with fully qualified name, so that it will definitely improve the performance. For example, if we want to call us a particular table name inside table, so it should be schema name followed by table name with a column name. That's this is because like whenever it will get executed, or at the time of compilation, it will locate that column name very quickly, and your execution or final result will be shown on the screen, or given back to your column. Moving on to the next. Yeah, based on our requirement, we can divide our stored procedures and public stored procedure, or whether if we are calling those stored procedure inside our all other stored procedure, we can say those as an sub stored procedure. We can give their we can give their allocation accordingly, so that it will be accessible accessed in that number of ways. Sorry. Yeah. In case of error handling, it's good to have updating these two fields, sys message or sp underscore add message, so that whatever error comes in, that will be shown on job log of our IBMI system, where job actually runs in, and it will be very useful when we need to troubleshoot if there are any consequences after executing that stored procedure. Coming back to the UDFs, since we have seen UDF are converted into SQL queries, and that eventually will get it compiled into a static SQL packages. So if there are any chances to get an error, we would not get the actual loophole where that particular error caught in. So it's better to have segregated all the UDFs if at all, and it should be properly giving some error handling scenarios. And if there are in any case, if there are going to be an unhandled thing, it should be given out some return message, something like returning error as an zeros or one. Moving to next thing. Yeah, here we can take one example. Let's say we do have three procedures: um, procedure X, procedure Y, and procedure Z. So from where we are directly calling procedure X, which will eventually call procedure Y. It will do its all calculation, and for some of the data, it will go to procedure Z again, and after doing its process, it will get all the result accumulated with it. So in traditional way, what we were doing, we will be returning those results back to procedure Y, and then procedure Y will not do anything on that result part. It will just pass on to procedure X. So to overcome this extra thing that we need to share with procedure Y, we got one special function or special characteristics for result set, so that we can return those result set directly to the caller from where it is get called. Here caller we can represent it as an first program that is being called in our call stack. So here we do have some sort of code blocks, set result set with return to caller. By this way, whatever is there in array 1 with HVL number of rows, it will get returned back to the caller. And here I would like to mention few points that will help us to in day-to-day life. It's in our development stage, whenever we are compiling any stored procedure code on the system, and as Ravi already notified, like when we have compiled any stored procedure, our system catalog tables will get updated accordingly, and it will execute from there. So it's advisable that whenever we are doing or promoting any codes to our production layer or next layer, it is always we should be compiling that stored procedure or recreating those stored procedure at that particular machine, so that there will be no any hiccups, and all system catalog tables will be updated accordingly. So next, again, like I would like to notify here, we should be writing code of stored procedure. If there are only SQL stored procedure, we should be using different code blocks for different set of statement we should be executing, which will leads to segregate all the complex logics. And also in case of troubleshooting, it will be very much good to get the exact point where we got the error. uh, there are some catalog tables already mentioned, like sysprocs and sysfunction. There is another thing like sysparams, which will keep a track on how many parameters are being passed to a stored procedure and UDFs. So these all things we can get to from the catalog tables. If whenever we have compiled those, we can make sure by seeing those catalog tables whether it is been deployed or compiled it with our desired values or not. And again, I would say, like after creation on stored procedure, it may possible like our database statistics, that means like if we have designed a stored procedure long ago where it was designed in a way that it will handle just only uh, thousand or millions of records. And after a day that comes in, our data will flow very drastically. At the time, what we usually do, we create a few indexes, and those indexes will be applied on tables, but we are not focusing on the stored procedure which are already created. And at the time of compilation, as we have seen, queries are compiled into static way and keep it into a SQL package. So whenever such things are happened on our uh, machine, so it's very advisable, like we should be recreating those SQL package, or nowadays we do have some additional rebuild statistic command is available that should be executed in particular intervals of time. So that will applies to our queries. Those are getting used in our program. Now coming back to, like we do have latest thing as an new feature, uh, that arrays comes into a picture. If we need to retrieve multiple rows in a single SQL query execution, we should be using this array. This array function, array data type, we can create by this syntax: create type int array. Int array will be a variable name, and it will be as an integer type of array of 100 elements. So once we have created this int array as a data type, if we want to define multiple variables with same name, same characteristics, we can define as we required. Something like that: declare integer a with int array. So it will directly copy from here and get it assigned to this type. Same thing like for character array, we would be getting this character array thing as an character 10 with array as an varchar 10 values. Now, here comes the difference in these two ways. We can have the arrays in two different types. One is for ordinary arrays, second will be a associative array. In ordinary array, where comes in, we are defining dimension as a constant one, and that will give us freedom to use that array element by using direct that index type. And whenever you are using associative array, it will be giving us freedom to increase or decrease size of that array, and that will be a more efficient way, I would say, according to our buffer storage comes into the picture. So these are all the things we have covered.
Okay.
Yeah.
Thank you, Yogesh and Ravi, for this session. We have some open questions, so if we can answer those. So the first in line is, what is the specific purpose of UDF when the same report can be generated with the help of SQL stored procedures, and SP also can be invoked from ODBC or JDBC client SQL statements?
Yeah, in terms of wherever compilation happens, we already discussed that stored procedure will be having two different types: procedural logic and SQL queries. Those are pre-compiled and stored in package. At the runtime, that will it will be executing. That's the only difference between stored procedure. And same realized from if we are executing them from JDBC, ODBC also.
The next is, both SP and UDFs are defined and created by developer or user. So what is the exact difference between them?
I think we already covered in the previous answer.
Okay. Uh, can we call the UDFs directly?
UDF
No,
for,
we cannot call them directly. It has to be inside SQL statements. It has to be wrapped inside SQL statements.
Okay. How to get multiple output parameters from UDF?
Uh, it is not possible to get multiple output parameters from the UDF, and for that purpose only we have this tabular function where we get multiple rows.
Okay. Uh, as we are already on time, so we'll take one more question. And is the stored procedure and SQL PL the same?
Uh, yes and no. PLSQL is the de facto language for forwarding the SQL statements. And they can also have the stored procedures by itself. But what we talk today is about the DB2 SQL stored procedures. Even though both of them they will share some of those capabilities, some of those features, but both are different.
Yeah. Okay. So just one more thing I would like to mention, that programmers.io have composed a new IBMI ebook to help professionals access essential resource to navigate the rising challenges. And our developers guide to mastering IBMI concepts combines practical and theoretical knowledge in one place to help professionals gain hands-on experience and a deeper understanding of technology. So you can go and visit the website, and we have pinned the link in the chat box also. And also, if you have any more queries which are still unanswered, you can reach out to us and send your queries to us, and we will respond on the same. Thank you all for joining and giving your valuable time. Thank you.
thank you.
Thank you, everyone.